Hi everyone, welcome to our new episode of Math Tutorial. This is your teacher, Sir Randy, as always. I'd like to welcome you to a new topic for grade 10, the fundamental counting principle. The fundamental counting principle, also called the counting rule, is a way to figure out the number of outcomes in a probability problem. Okay, basically you multiply the events together to the total number of outcomes. So for us to be guided, we have this essential question. How is the counting principle applied to determine outcomes? The fundamental counting principle could be of two events, three events, more than three events, okay, different situations. In the case of counting wherein there are only two events, if you have two events, one event can occur m ways and another event can occur n ways. Then the number of ways that both can occur is m times n. So for example, we have two events here, event 1 and event 2. And there's a problem, how many different types of sandwiches? So we are to count how many different types of sandwiches, okay, according to the problem. So by the principle, you're just to follow when there are two events, the m times n. So that's why we have 4 times 3. So it's equal to 12. 4 is for your m and 3 is for your n. In the case of counting, wherein there are three events, okay, three events can occur m, n, and p ways. Then the number of ways all three can occur is m times n times p. So example of the events that we have here, and then there's a problem, how many different sandwiches you can make or can you make? All right, so the principle just told us to multiply m times n and p. So that's what we have here. 4 times 3 times 3 is equal to 36. That means there are 36 different sandwiches that you can make out of the three events that were given. So what about if you'll be counting, applying it already to more than three events? Okay, more than three events. Yes, for example, at the restaurant at Centrio, you have the choice of 8 different entries, 2 different salads, 12 different drinks, and 6 different desserts. How many different dinners? One choice of each. Can you choose? Alright, that's the problem. So you're just going to, yeah, there are 4 events here. You're just going to make multiplication of multiplying 8 by 2 by 12 by 6. So you have 8 times 2 times 12 times 6, and that you can have 1152 different dinners. So you have the number of different dinners, the count of different dinners. There are instances that in your counting, um, there is repetition. So in the fundamental counting principle, wherein there is repetition, it's best understood using this example. For example, the LTO license plates have three numbers followed by three letters. Now, I think this is the old plate, no, old plate numbers that we have here in the Philippines. How many different license plates are possible? Digits and letters can be repeated. So digits and letters can be repeated. So remember there are three digits and three letters. So six characters in all. So there are 10 choices for digits and 26 choices for letters. Why 10 choices for digits? Because that's from 0 to 9, and for the letters that's A to Z. So with repetition, that means there's always 10 choices for the first number, another 10 choices for the next number, another 10 choices for the next number. Alright, because it's repeated. Same with the letters. So 26, 26, 26. That's why we can solve it multiplying 10 times 10 times 10 times 26 times 26 times 26. Thus, you can have 17,576,000 different plates that can be formed or created. Okay? In the situation that counting is without repetition, so the fundamental counting principle without repetition. And for example, the problem, how many plates are passable if digits and numbers cannot be repeated? Based on the problem a while ago, and the above problem, the LTO plates, no licenses plates. There are still 10 choices for the first digit, but only 9 choices for the second and 8 for the third, of course, because we cannot let the number repeat, right? For the letters, of course, there are 26 for the first, but 25 for the next, since if you got the first, how many were left? Were 25. If you get the second, how many were left? Were 24. So that's for the third. That's why you can count. I mean, you can get the total counting using the operation 10 times 9 times 8, 10, and then times 26 times 25 times 24. You all have 11,232,000 plates. Okay, so we can count it all. The fundamental counting principle also could be of other examples like phone numbers. The problem goes this way. How many different 7-digit phone numbers are possible if the first digit cannot be 0 or 1? For example, the telephone company, the company is um, creating a roster of numbers, and that they wanted to just have 7 digits in all numbers that they have to assign, right? So how many different 7-digit phone numbers are possible if the first digit cannot be a 0 or a 1? So it can't be a 0 or 1. Remember, if we'll be using numbers, we have 10 choices, no, as we mentioned a while ago, since it include 1, I mean 0 to 9. So there are 10. So if we will exclude 0 or 1, I mean 0 and 1, so we can have only 2 to 8. That is composed of 2, 3, 4, 5, 6, 7, 8. Total of 8 numbers for you to choose from for your first digit, and the rest you can choose from 0 to 9. That's why we have 10, 8 times 10 times 10 times 10 times 10 times 10. You notice that there are 10, I mean there are 6 tens because that's for the second, third, fourth, fifth, sixth, and seventh digit. And our first digit could only be either 2, 3, 4, 5, 6, 7, 8. Now, you choose from those numbers. Right, and then if you get the product of that one, that will give us the total count of different numbers, which is 8 million. 8 million total count of different numbers. That means different 7-digit phone numbers. Ang dami. Alright, it can also be like an example for testing and testing, alright? A multiple choice test given to you by your teacher has 10 questions with 4 answers each, like A, B, C, D choices. Now, you think that the quiz is just very short because it's only 10 items and with 4 choices, but if you knew already counting principle, you would say, oh my god, there are, a lot of ways to complete the test, even if it's only 10 items, because you will have the 4 times 4 times 4 times 4 times, so that means 4 raised to 10, because there are 4 choices in every item and there are 10 items, so you can have this counting, all right, and you can have the total count of numbers 1,048,576. So that means this number refers to the number of ways one can complete the test, which is 10 items quiz, and with 4 choices in every item. I think that's it. That's all about the fundamental counting principle or the simple counting principle. Again, this has been your teacher, Sir Renren. Thank you for watching.